Section 4.4, factoring quadratic expressions. So today we're going to take a look at factoring. We'll factor trinomials, we'll factor the greatest common factor, we're going to factor some perfect square trinomials, and the difference of two squares. So remember, factoring is rewriting an expression as the product of its factors. So back in Algebra 1 and even a little bit in geometry, we saw the idea of foiling, where we took two binomials and we foiled out their values, or we used the distributive property depending on how you wanted to approach this, and then you created a trinomial, a quadratic trinomial. Factoring is the process of undoing that, or figuring out what the quantities you started with were before you multiplied them together. All right, so you should remember some of this from Algebra 1. If not, hopefully this is a refresher and it comes back to you really quickly. So here we are looking at factoring a trinomial with a leading coefficient of 1 or negative 1. And so a lot of you will remember this as being the quick way to factor, where you're looking at your C values and then using that to determine how they create your B value, and then breaking apart into your two binomials. So for this first example, I have x squared plus 9x plus 20. What I want to do is I want to figure out what two numbers are going to multiply to be a positive 20, but add to be 9. And so you could list out all of your factors for 20. So you've got 1 and 20, 2 and 10, 4 and 5, and I think that's it. And then look across and say which two add up to be 9. Well, these are going to add up to be 9 when you add them. So that means your factored form here is we're going to split this into two binomials. We're going to have x plus 4 and x plus 5. This is your factored form. Question 2, same idea. We're looking for the factors that multiply to be negative 72 but add to be 14. Since it's a negative 72, one value has to be positive, one has to be negative. And so we can list all of these out. So I can list out all of the factors of negative 72, and then I'm merely looking for the two that are going to add up to be a positive 14. Well, this doesn't work, doesn't work, doesn't work, doesn't work, doesn't work, doesn't work. Ah, positive 14, here we go. So these two factors make up, or they multiply to be negative 72, but add to be 14. So what I can do now is I'm going to split this into two binomials. I've got x minus 4 and x plus 18. If I foiled this back out, I would get the trinomial I started with. This time we have an a value of negative 1. In Algebra 1, we never really factored any of this form, but it's an easy fix. So what we're going to do, in order to make this look like the previous examples we've done before, we're going to go ahead and factor out a negative 1 through the entire thing. So instead of being this, we're going to get negative 1 on the outside, and then we're left with x squared minus 13x plus 12. What we want to do now is we want to find two numbers that multiply to be 12 but add to be negative 13. Because that middle number is negative and our C value is positive, that means both of our factors have to be negative values. And I already know what I'm going to be looking for, negative 12 and negative 1. So now I can go ahead and separate this. I'm going to have x minus 12 and then x minus 1. But I have to make sure I bring down the original negative 1 because it's now a part of the factoring process. So this is my factored form. So go ahead and pause the video here. Pause it, try these three problems, and then when you're ready to see the answers, unpause it. So next we're moving on to the greatest common factor. The greatest common factor of an expression is a common factor of terms in the expression. All right, it's the common factor with the greatest coefficient and the greatest exponent. And so ideally here, if you look at the first example here, you're going to notice that this is not a trinomial, so it's not going to get factored the same way as the ones we did prior. Instead, the best we can do for this to start off with is look for the greatest common factor amongst our coefficients and our variables. So in this case, we're thinking about what is the greatest common factor between 6 and 9? Well, I know it to be 3. And then I have to think about, what do n squared and n have in common? Well, the most they're going to have in common is a single variable n. So that means our GCF in this case is 3n. So when I go to factor this, I'm going to have 3n, and then inside my parentheses I want everything that remains. So what I'm going to do is I'm going to take this 3n and I'm going to divide all of these items by that. So 6 divided by 3 is 2. N squared divided by n, essentially with a variable you're going to subtract the exponents, and so that becomes n to the first. 9 divided by 3 is 3, and then the n's would cancel. So this becomes our factored form. 3n times 2n plus 3. Sometimes it becomes necessary to factor out the greatest common factor just to make the problem easier. So in example B, notice here that every single term is divisible by 4. So we're going to kind of factor out 4. So that means we're going to be looking at having 4 times x squared plus, well, 20 divided by 4 is 5, and then 56 divided by 4 is 14. And so this is our new problem. But now, looking inside here, we can factor this even farther. Two numbers that multiply to be negative 14 but add to be 5. Well, that's going to be 7 and negative 2. So we can then factor this one more time. So this trinomial is going to split apart to x plus 7 and x minus 2, and we'll carry down our 4. And so this is our completed factored form. All right, go ahead and pause the video again and give these 3 problems a shot. When you're ready to see the answer, unpause it. So the first problem, you're just factoring out the GCF of 7. Then you're left with n squared minus 3. In the second problem, or B here, you factor out a 9 first, reduce your trinomial, and then factor it again to get 9 times the quantity x plus 2 times the quantity x minus 1. For C, the only thing you can factor out is the GCF of 4, so you're left with 4 times the quantity x squared plus 2x plus 3. All right, now it's time to look at factoring trinomials with a values or leading values of a that are greater than 1, or not equal to 1 at least. So in this case, we have 2x squared plus 11x plus 12. There's no GCF that's going to help us factor this or make it smaller. So what we have to do is we have to remember 2 different methods that we may have learned in order to factor this. The first way, let's see, we're going to try slide divide factoring. All right, so we're going to do this same problem 2 different ways. So we have slide divide, and then over here we'll do what they call grouping. So for slide divide, we're going to take our 2x squared plus 11x plus 12, and we're going to slide our a value back. We're going to multiply it back this way. We're sliding it back through multiplication. So we're going to get x squared plus 11x plus 24. Now we're going to try to factor this like we would before. 2 numbers that multiply to be 24 but add to be 11. Well, I know that's going to be 8 and 3. So we've got x plus 8 and x plus 3. The reason they call this slide divide is now that we've slid this back, we now have to try to divide our new factors by our original a value. And if it divides, you go ahead and divide it into it evenly. So this would be x plus 4. If it does not divide evenly, you're going to slide it back out in front, or what they call bottoms up. So this becomes 2x plus 3. And so here's your factored form. So that's slide divide factoring. Now we're going to take a look at factor by grouping. And so we should get the same answer, but the procedures are a little different. So factor by grouping, what we're going to do is we're going to take our a value and our c value, and we're going to multiply them together. So we're going to get AC, in this case 2 times 12 is 24. Since our 24 is positive and our 11 is positive, we're looking for 2 factors that are going to multiply to be 24 but add to be 11. So this is kind of similar to the slide divide. And so I already know that it's going to be 8 and 3. But this time we're going to write this slightly differently. We're going to replace the 11x here with an 8x and a 3x. And now we're going to have 2x squared plus 8x plus 3x plus 12. And what we want to do now is we want to group the first two terms and the last two terms. Once we have them grouped, we're going to try to factor a GCF out from each group. So 2x squared and 8x have a 2x in common, so I'll factor out 2x. And so I'm left behind with x plus 4. And then here, 3x and 12 have a 3 in common, so I'll factor out a 3, and I'm left with x plus 4. You know you've done this correctly when the quantities here are the same. That's the key. And so now, right now I know my final answer because one of my binomials in my answer is the two GCFs put together, so 2x plus 3. The other is the repeated binomial. And so this is my factored form. They're the same, so I know I've done it right. Either method will get you to an answer. It ultimately depends on which one you're more comfortable with or more familiar with. So this is grouping, this is slide divide. Let's try one more like this. So here we've got 4x squared minus 4x minus 3. We'll do slide divide here. So for slide divide, we've got 4x squared minus 4x minus 3. I will slide this back. This is going to become x squared minus 4x minus 12. Now I'm going to look for the factors of negative 12 that add to be negative 4. Well, that's going to be negative 6 and positive 2. So I've got x minus 6, x plus 2. Now I want to divide by that leading coefficient that was 4 here. So I'm dividing by 4 and 4. In neither of these cases does the 4 go evenly into the number above it. But what does happen is we can reduce these. So let's reduce these. So we're going to have x minus, instead of 6/4, we're going to have 3 over 2. And then we're going to have x plus 2 over 4 would be 1/2. 2 still doesn't go evenly into the number above it, so what we're going to do is we're going to slide it back out in front, or what they say is bottoms up. So we slide it back out in front. So our factored forms are going to be 2x minus 3 and 2x plus 1. So sometimes with slide divide, your factor does not go evenly into the numbers, and you have to then reduce and then slide it out. All right, so there's slide divide. So now let's look at grouping again. So grouping, we're going to have 4x squared minus 4x minus 3. Let's find our AC value. Well, that's going to be 4 times 3, which is negative 12. We already know the factors from the previous example, so we're going to have 4x squared, and then we're breaking this apart into negative 6x. And then we'll do positive 2x, and then minus 3. So now we need to group our first two terms and our last two terms. The GCF of 4x squared and 6x is 2x, and we're left behind with 2x minus 3. The GCF of 2x and 3 is just 1, so we'll say plus 1, and we've got 2x minus 3. Notice here that they match. That's what we want. And so our final form, when we bring these together, is 2x plus 1 and 2x minus 3. Same answers, different methods. Go ahead and pause the video and give these two problems a shot. We want to make sure that we put the square there. All right, go ahead and pause the video, give them a shot, and check your answers when you're done. So the first problem I tackled with grouping and ended up with x plus 1 times the quantity 4x plus 3. The second problem I chose to do slide divide, and I've got 2x minus 3 times the quantity x minus 2. So a perfect square trinomial is a trinomial that is the square of a binomial. All right, so that means that if we were to factor such as x squared plus 10x plus 25, we get the same quantity twice for our two binomials. So in this case, x plus 5 times x plus 5. So here are some shortcuts to help us identify these things. So you can tell if ax squared plus bx plus c is a perfect square trinomial by looking at your a and your c values. So your a value, in this case ax squared, ax and c are both perfect squares, and then b is the combination of those squares together. So in this case, as we look here, they kind of give you an indication of what you're looking at. So if you have, let's say we have 25 x squared, and then here we have 4 as the other value. The square root of 25 is 5, the square root of 4 is 2, so that means in the middle here, when we multiply those together, we get 10, double that, you get 20. So your perfect square trinomial will be 20x. So it would look like something like this. So as you start to dissect this, you can then use this shortcut to tell you how you're going to get your factored form. If the values are both addition, you're going to have a plus b squared. If the b value is negative, or you have the subtraction here and then addition here, it's going to be a minus b squared. All right, so these are kind of shortcuts. You can still use the previous methods we've talked about for factoring to factor, but these are kind of trying to give you a quick way to get to an answer or to visualize what you're trying to do. So here we've got what is 4x squared minus 24x plus 36 in factored form. So notice here that in this case, this is a perfect square and this is a perfect square. The square root of 4 is 2. The square root of 36 is 6. If you take 2 times 6, you get 12, and double it, you get 24. So this is a perfect example of a perfect square trinomial. And since we have a subtraction sign here, we know that we're going to be looking at this form. So we want to write this in factored form. Well, we're going to take a. Well, a would be 2, and it would be 2x, because we'd square root the x squared as well, and then minus 36 square rooted, which would be 6 and squared. So there'd be our answer. We're going to do the same thing in b. Notice here that 64x squared is just 8x. Here, 1 squared is, or square root of 1 is 1. So the square root of 64x squared is 8x. The square root of 1 is just 1. 8x times 1 is 8x. Double it, you get 16x, so that's the middle we're looking for. And notice that this is subtraction again, so we're going to have our factored form is 8x minus 1 squared. Just so we're aware, let's look at a different, I'll add an example here. So let's say we had 25x squared plus 20x plus 4. In this case, we know that 25 square rooted is 5. This would be 5x. This would be 2. 2 times 5 is 10, so 10x. 10x doubled gives you 20x. So this is a perfect square trinomial. Both of these are addition, so the factored form would be 5x plus 2 squared. Here we have a squared minus b squared is what they consider to be the difference of two squares. There is no pattern to its factor. Or sorry, there's a pattern to its factors. Sorry, there's no pattern. There is a pattern to its factors. So here they're giving us this illustration of the key concept. If we know that we have perfect square here and a perfect square here separated by subtraction, then to factor this, we're just taking the square root of a and b and creating one quantity with addition and one with subtraction. So as we look here, 25x squared is a perfect square, 49 is a perfect square. They have the subtraction sign, so we know we're dealing with the difference of two squares. So the square root of 25 is 5, square root of x squared is x, square root of 49 is 7, and so we're going to have one with subtraction, and then we have the other with addition. And there's our factored form. Same idea here. As we look at 16x squared and 81, 16x is a perfect square, so is 81, and we have the subtraction. So once again, the difference of two squares. So this is going to be square root of 16 is 4, x squared is x, and then 81 is 9. So 1 addition, and then 1 subtraction. And there's our factored form.